Test 1, 2, 3. Good afternoon. Welcome to the communication session in June. We have three topics where, if you look at the agenda, I will start with the updates. Then we will say something about the growth plan, and then we have a special topic from Colin, hardware hacking in the Mindbox. A small update. There are three topics basically. One is the DNS issue, which is a very important P1 with serious impact to our organization. And I will tell you a little bit more where we are in finding the root cause of that issue. Then the agile way of working. I'll tell you more about what we are doing in that area. And then also a third area where we have experienced some issues in onboarding T-Systems, to give you an update on that as well, to make sure that everybody is aligned on the situation that we have with T-Systems. Well, if we look at the DNS issue, I must say it was end of May, 30th of May, where we had this issue. So we are now already 1 month later, and it was very difficult to really find the root cause. With DNS, if changes are made, they're replicated to other DNS servers, and also in terms of logging. First of all, we don't have all the audit loggings on our systems. That was a choice in the past, also because of cost, because you need a special license with Microsoft, which is very expensive. We do have activities logs on the servers, and after the first analysis of Microsoft, we have identified which servers we need the logging, and we were able to restore them and analyze them together with Microsoft and Cognizant. Still working on it. Last update I received is that there are different scenarios that we see as possible scenarios that have led to the DNS issue. The area we are thinking about is that on the 17th there were some changes for the holding, and because of the structure that we have in DNS, which is not always logical, made from the past, certain consequences happened 2 weeks later. Again, we are still working on that, but tomorrow the final RCA will be ready, and also I will share that also internally, so everybody can see and read what is written down. And I don't think we have 100% root cause. This is what happened at this time with these consequences, but this is the highly possible course based on the information available that we have been able to identify. And that's also a learning for us, that we have to look how can we improve that if something like this will happen again, that we have enough information to quickly identify the root cause. And because our customers are of course very much waiting on this outcome, because the impact for our customers was pretty high. And especially the companies outside PON, like the dealers, were not able to sell cars at that moment. They're not happy, of course. So something with really high impact. Further, of course, what else can we do in the area to prevent that this will happen again? Looking at authorization of people, how much domain admin do people have to make these kind of changes, which are replicated through all our environment? Is it really needed that those people need that kind of access all the time, or just at moments when they need to make such a change? And those are also areas where we will look into. I just want to emphasize that there is a lot of focus on the DNS issue to really get everything above the table that we are able to find, to learn from it, and to explain to the business what happened and what we will do about it. Then another topic, the agile way of working. Last week there was an IT conference where certain IT people globally, IT managers, have come together, where We Drive Digital Innovation was the topic. We have seen presentations of companies like Wekamp, ING, to learn how they have changed their organization to a more agile way of working, which was very inspiring. And if I look back in the last 2-3 years, we have done a couple of attempts, certainly in the infrastructure area, to get experience with the agile way of working. Sometimes the initiative died also later. But I think we are now more mature. We also know better how we can use it. Recently, we started in the cloud team to start also with the agile way of working, where I see some positive outcomes on that, and I will show some more initiatives on the next slide. But why are we doing, the agile way of working? It's a nice buzzword. It's like cloud. It's used a lot, but what will it bring us? And what I learned last week from the other companies that transparency in that way of working is a very important item. Being transparent on what you are doing, why you are doing it, what's the priority of certain things will help to focus, and that's the next part. But also to share failures. And to give you an example, in Wacom they have with Slack they have a room where all the P1 incidents is communicated about. And if you imagine that there are 600 people at Wacom, and in the IT organization there are roughly 125 people, there are 300 people in that room following everything about P1 incidents. So from the techies typing in what they're doing, what went wrong, how to fix it, to showing the root cause. So everything is a sort of live stream, and everybody can look into it if he is interested. So that gives a lot of transparency about things that is going wrong. People learn from it. The business also knows what is happening, that IT is working on it to get it fixed as soon as possible, and it helps them a lot to work more closely together with the business. And also another nice thing that they can do is they have a bot behind it, and they can ask the bot, okay, what's the current sales from the last hour? And immediately the bot shows how much they have sold in the last hour. And so if there is a certain P1 with impact to business, they can also see directly what's the financial impact if you cannot sell through the Wacom site. And so a lot of innovations, a lot of things that they are doing, which is also part of the agile way of working. And so also thing for us to think about what can we use in our environment to take advantage of that. Priority setting I mentioned, and alignment with the business. You see it also in the Scrum method that there is a product owner coming from the business, giving priority on the things that should happen, and that helps a lot to steer our activities in the way we give them the right priorities. And if you look at our agile initiatives at the moment, is that, like I mentioned in the cloud team, we do a daily stand-up. We started with just looking, okay, how many incidents do we have open, how many changes, how many project tasks needs to be executed, and by trying that and communicating about it, what are you working on today, what did you do yesterday, what kind of issues did you experience, so your colleagues can immediately help you out, or if you don't know that, I can help you with that. That gives transparency and focus. We're now moving to the phase that we try to understand how can we have weekly sprints. So clearly what is the priority and what will we finish by the end of the week, and also get the alignment with the engagement managers so they know what is included in the sprint, what will be ready, and how can I manage the expectations of my customers. So learning, taking small steps. If something doesn't work, we will stop with it and we try something new. But that's the new way of working, and that we get more experience in agile and understand what it can bring to us. Because we only do it if it will help us in a better performance of PON IT. So that I move back. Also operational excellence, doing a 2-week sprint in DevOps to come with new releases. So they started there as well. Finance, also starting with sprints to at least show a backlog of the activities that they have to work on, and spread the work across the team. And a new initiative which we discussed last week in the management team, where we talked about agile working, is that if you want to have the most benefit of agile working, you have to focus on the customer. And we thought, okay, where can we have that experience? Where can we have the first steps to experience working focused from multidisciplinary teams on one customer? And for us, the bike group is the most logical candidate. Because there are a lot of initiatives that we are doing with the bike group. Gazelle wants to use PON IT for their network and possible other services. We have Derby in Germany that wants to bring a lot of services to PON IT. We have Santa Cruz in the US that wants to host their SAP platform with us. So on multiple areas we see initiatives from the BY Group to do more with PON IT, which is absolutely great, of course, but we have to do it good. We want to make that a success. And having a multidisciplinary teams from network, from cloud, from all the areas together, working together in a team, will help to create focus, to have better alignment with the customer, and to experience how that new way of working can help us. So Gabriela is leading that initiative to set it up in the next 2-3 weeks. So you will hear more about that. But I'm very enthusiastic that at least we try to do these kind of things and get the experience and see how we can move forward with PON IT in an infrastructure environment, which is absolutely different than the application development that they're doing with digital solutions, but just see, learn, and apply the new way of working to our organization. And the last point, also other departments are interested. Sometimes they ask, can I join the cloud stand-ups to see what they are doing so I can learn from it and see how I can apply it to my own department. And yes, of course, we need to stimulate that, learn from it. And maybe it's logical to move the network and the cloud team together in a daily stand-up, because there are a lot of initiatives which have a network component and a cloud component. So also these kind of things we're thinking about, how can we improve our performance from that way of working. Then the last one, T-Systems, and I have sent out a communication about it, just the latest about this. I had a meeting with the CEO of T-Systems because of some things with T-Systems that didn't work out the way we expected, and we had some serious production issues in Scandinavia, but also with our firewall here in the Netherlands, which was absolutely not acceptable, the way that was done, doing changes without a proper approval. But also, delaying in the way they deliver the service to us. It's not the speed that we need and that we have contracted. So I had a good conversation with their CEO, explained why we have chosen for T-Systems, why we need that strategic partnership from them, and how to make that a success, and what has happened in the last year which didn't work out as a success. And the CEO apologized for the performance of T-Systems. I really felt sorry, and after our visit he has had calls with his VPs, and he took it very serious. So he brought a team from Germany to the Netherlands, worked over the weekend to work on a new plan. So I see the first steps. I think also Miriam this week, we have a good team there now working on SIAM. We see improvements, so that's positive. But we are also preparing a plan with clear milestones. What do they need to deliver, under which conditions, so that we accept their delivery, and if not, what will be the consequences. So we put a bit more pressure on T-Systems now to make it a success, but also if they don't deliver, what will then be our next step. Just to be transparent, like I said, transparency is important, so also on that area I want to be transparent within PON IT, so you know. So if you have questions, you know what we are working on. But I also must say, I really hope and believe that we still can make this a good success, and that's absolutely in our interest. It's not in our interest to stop with T-Systems. It's a strategic relationship, and if we stop it, it will have a huge impact for PON IT. So let's all work together to help T-Systems, to work closely with them together to make a success of this partnership. Then the growth plan.
Yes.
Last day at PON IT.
Yes.
Thank you.
Thank you. Hello everyone. I will tell you something about the growth plan, which I worked on for my period that I was here. Well, these are the things that I will tell you something about today. I will tell something. I will introduce myself. I will tell you something about the goal of the growth plan, my plan of approach, and I will share the results with you. Well, first of all, my name is Rieder Ravenswaay. For the people that don't know me yet, this is my last day. Well, I'm 25 years old. I'm studying economics at Windesheim Flevoland in Almere, and tomorrow I will hear if I graduated or not, so fingers crossed. For the last for the past 20 weeks, I was the customer experience intern, and these are a few projects I helped with. I helped with the third edition of the IT magazine, the Pon IT Services and Projects Google Plus community. I helped with the service catalog go live. I also help with the Meet the Business initiative, so the site visits. If you haven't signed up yet, please do it, because it's a really fun day with your colleagues. And I also help a bit with the IT conference. But my main project was the growth plan, and I would like to share the results with you. So I think this sheet will look familiar to all of you. As you can see, our ambition is to be the #1 IT partner for PON worldwide by 2020. And on top of the list, there's growth. So a minimum coverage per service of 70% within PON. And in line with the ambition of PON IT to grow, there's a need of a growth plan. And PON IT isn't sure about where to start and how to reach the goal of 70%. So the goal is of this project to deliver a growth plan which answers the following questions. So which business groups or opcos has for PON IT the most opportunity to grow, and with what services? Well, my plan of approach. I use these 5 design principles. #1, commercial thinking. To grow, it's important to think in a commercial way, because to grow we have to sell services, so we have to think in a commercial way. It was also important to have insight in all relevant available data within PON IT of all the customers. PON IT strategy more in the new sales approach, just think about the customer experience, synergy and joint innovation, and stuff like that. And we also need to focus on the needs of the opcos. And these needs of the opcos we need to combine with our services. Unfortunately, I was here for only 20 weeks, and I couldn't make it to step #5, so the final growth plan, because we're still at step #4. So I will tell you something about step 1, 2, 3, and that's what I've done these past 20 weeks. First of all, 1.1 is the list of current coverage per service. Within PON IT there was a document filled in by all the service managers, and with a percentage of coverage per opco per service. All these opcos, I put it in a spreadsheet divided by business group. So you have a clear overview of every opco and every service. If it's not clear yet, I will come to that later. 1.2, we made a hard and soft pipeline with engagement managers. So the soft pipeline is when the opco has interest in a certain service of PON IT, but the conversations are at the beginning phase. And the hard pipeline is more when there are already proposals are already made, and when the signature of the opco is nearby. Third, 1.3, customer segmentation. During different meetings with engagement managers and service managers, we discussed different customer segmentation principles. I will also come to that later. And we also graded every opco, every customer segmentation principle on every opco. Step 2 was made a selection of the most attractive potential customers. And step #3 is list the needs of select customers and link them to PON IT services. So the results. These are the customer segmentation principles which we used. So we have potential growth for PON IT. So we looked, the customer segmentation principles were scored on a scale of 1 to 5, and they were filled in by the engagement managers based on their customer insights. #1, potential growth for PON IT. So it's about the potential growth of PON IT in the future. We also gave every customer segmentation principle a weighting factor. #2, financial interest. So how much money can we earn right now, or how much money do we earn right now per month per opco? Flexibility. So flexibility in contracts regarding other IT suppliers, effort, how much effort the Spawn IT needs to make on three aspects. So technical aspect, the politics aspect, so how important is stakeholder management, and the distance to the OPCO, like is it in Europe or America or Asia, stuff like that, and strategic interest. For example, if one OPCO will onboard, the other in the business group will follow. So these are examples of the most attractive potential customers. I filled the document in half of April, end of April, so it could be that the percentages are not correct yet. So BB Cycling and Continental Bundle Group are already started the onboarding, and on the end you can see the total score of the customer segmentation principles. So these OPCOs have the lowest current coverage in percentages and the highest score of customer segmentation principles. So these are actually the results. There's a monthly meeting to review the focus with the engagement managers and service managers. So on the right we have on the left for you we have a soft pipeline, hard pipeline, and the projects which are already started. So this is a document which I told you about, the spreadsheet. So every OPCO is divided in every business group. I think it's not clear for you to see, but I'm going to explain it a little bit so you have a more clear idea of how it looks. Every OPCO has the less codes, the number of sites, the address, and which country the OPCO is. And on the right, you can see every category of services and every service which we deliver in every category with the percentages of which Pon IT delivers to the OPCO. And in the end, you see a total coverage per OPCO. And yeah, step 4 and 5. So I'm not there yet, but the stakeholder map and account plan for OPCO, that is something that needs to be done, and that will be done by the engagement manager. So I think that's it. Are there any questions? I'm not sure if it's clear yet, but
Yes, it is.
Thanks a lot for all the work. It really helped us in our, number one strategy priority to grow the business of Pon IT.
yeah,
So thanks for your help, and I have no doubts that you will graduate.
yeah, thank you.
Please let us know.
I'm sorry if it's not clear, if not everything is clear, but I'm a bit nervous, so.
That's good.
Yeah, okay.
Thank you. Thanks a lot.
Thank you.
The next one is Colin. Also your last day here at Pon. And also you helped us a lot after Thomas Janke leaving last year in September. And you really contributed together with Tim on the security part. So very interested to hear your story here.
Yeah. Well, thank you. Welcome everyone. I'm going to talk a bit about the security and privacy team and the work that is done in that team. Maybe some things you don't really expect. And then I want to dive deeper into one project, which is the Mindbox, which I had a look at. A bit about me. I'm Colin Chapin. I'm a cybersecurity engineer. As Lisander said, I've been here since September, sort of. And today is my last day. I mainly focus on executing security tests on different kinds of systems and services, web applications, mobile apps, infrastructure. And I'm quite into automotive security. I did research into the security of cars, of connected cars, and there was an article was published about my research in the NRC, and this is also the topic of today. Within the security and privacy team, one of the things that happens is the execution of penetration tests, of security tests, and it's on various different kind of things, such as web applications. You see we found a cross-site scripting vulnerability, when we do these kind of tests, we try to break stuff. We try to fill in really weird things, so we get some error messages that we maybe can use to our advantage. One other thing is vulnerability management. Here you see the vulnerabilities that exists in the servers that we monitor. We do weekly scans, and we're trying to set up a program that all these vulnerabilities get fixed. One of my first things that I did when I came here was I had a look at the awareness engine. Just before the release, I had a look at the security level of the engine itself, because of course it also had to be secure, and I found some nice interesting things that hopefully Angeline didn't have too many headaches about the night before it went live. Some other web application SSL certificates, etc. Hidden admin panels that I found quite a few of, but also hardware and SCADA for PON Power, for Caterpillar. I took a look at some hardware they use. That's also the Mindbox. So the Mindbox is an initiative from PON. It's a step up to connected cars in the future. And I want to show a short video. And it's quite funny because it was made at the end of 2017, which is not that long ago. And I tried to depict what kind of mobility services would exist in the future. And actually some of them already exist now, or in the video back then.
It's time to go. Let's see how I'm getting home tonight.
Mobility managers use advanced analytics to combine Ben's trip history, current circumstances, data from millions of other commuters, and information from different modes of travel across the city to provide a set of tailored, seamless options. Payment providers allow Ben to pay by the mile. Insurance companies deliver customized per-trip insurance that accounts for Ben's particular route and mode of transit.
I need groceries. I can pick them up at the station and then take a pod home. But I can still get some exercise by biking to the train.
City planners work with the private sector to operate and maintain critical infrastructure, from bike racks to train platforms. Physical assets are increasingly smart and connected, allowing constant real-time monitoring.
Perfect timing. And I don't even need to take my phone out of my pocket to board.
Digital infrastructure suppliers provide ubiquitous, high-speed connectivity for a smooth and secure online experience.
Milk, eggs, bread, ice cream? Yeah, why not?
Retailers and logistics providers enable nearly on-demand provisioning of products to Ben.
Well, I got my groceries. Now I just need to grab a pod, and I can catch a bit of the game.
Fleet operators store, maintain, and deploy shared autonomous vehicles throughout the city. Vehicle manufacturers build an array of shared self-driving options to meet the varying needs of Ben and the millions of other travelers. Content providers offer a variety of options, from entertainment to business applications, each supported by advertisers and subscription fees.
Wow, that was fast. Now I just check the fare summary, grocery bill, rate the trip, and it's time to relax.
So you can see that some of these functionalities already exist today. We have the shared bikes, you see them a lot everywhere. And actually last month I saw at the Amsterdam Zuid NS station that they already offer entertainment there. You could log into a Wi-Fi network and have an app that shows you entertainment. So in 1.5 years a lot has happened already. And one of the things is also the Mindbox. I'm going to introduce the concept a bit for you, for those of you that don't know. It's a small box. It's a black box that can be installed into the car. It will be installed in the front of the car under the steering wheel, under a plastic, so you don't see it when you're driving, and it's tied directly into the internal network of the car. And there it can can see a lot of interesting information it can show you. The internals of a car, you can see the so-called CAN bus here, which is an internal network. So there's a lot of wiring in the car, because these days everything is electronic. It's not mechanical anymore like it used to be. If you press the brake pedal, there's actually a sensor that measures how much you press the pedal, and then over this CAN bus, it is communicated to the brakes on the wheels, which do the braking. So there's no mechanical interaction between the two anymore. So all this information goes over the CAN bus, like braking, like steering, like gas, and you can get a lot of interesting information on that if you're tied into it directly with your Mindbox. And that's what is shown to the user in the app and in the portal. So in the app you can see where your car is parked and how much you're driven and how well you're driving. And the portal is used by fleet operators to see all the cars that they are exploiting, and if some maybe need maintenance, etc. And this CAN protocol, this CAN bus, is quite old already. It was developed in the beginning of the 90s when there wasn't really a thought of security. So that's why we can read all the data for the Mindbox, but that also makes it quite interesting if you put this internet connected box into it. It could allow for some really interesting vulnerabilities. And that's why Mind asked us to take a look at the level of security. And we're really happy that they did. And before we started the test, we came up with a few threat scenarios. 4 scenarios that we were trying to focus on in the test. And the first is write access to the internal CAN bus. So you can imagine if you manage to hack this device, which is connected to the internet, you could go into the device itself at all time from everywhere around the world. If you then would be able to write messages onto the internal CAN bus, you could control the car from just your couch at home. You could press the brake, you could turn off the engine, you could boost up the speaker to play really loud music. So that was a big thing they wanted me to test. And the other ones are physical and wireless connections. You'll see in a bit that there are many connections in the CAN box. And then the last thing was, if you manage to hack one device, could you use the wireless connection to infect the central infrastructure and do something on the servers there, maybe possibly infect other Mindboxes that are scattered around the environment. In this presentation, I'm going to focus on 2 of those. Firstly, the physical connections, and then the write access to the CAN bus. So how do we go about doing that? So as I should just show you, I received one Mindbox from Mind to take a look at. We started looking at the outside. On the left, you can see the connectors that are used to connect to the CAN bus itself. The blue and purple ones are used for GPS and GSM connectivity. Here you can see a small micro USB port, which was quite interesting because we didn't know what it did, so maybe it could be used for something. Then we opened it up, and we saw something that made us quite happy. I don't know if you can see it on the picture here, but we saw some little holes in there. It didn't have anything, it was just holes. And those are debug interfaces, which are used by the developer while they're developing the board. They can have really easy access into the board to change some settings, to read some configuration, debug information, to make sure the box works all the time. And actually left them in there just as a whole, not as a connection, but they're still in there. So that's usually a really nice way in, because you can do a lot of things through those debug interfaces. So we wanted to connect to these interfaces. At first, let's take a look at all the components that are in there. You can see the SIM card holder, micro USB, flash memory, RAM memory, the debug interfaces as I just showed you. There's a processor, the GSM and GPS modules. As I showed you, the connectors. There's this other antenna that you plug into these connectors that provide the GSM and GPS connectivity. The CAN connectors, the CAN transceivers and controllers. Those translate all the messages that the processor sends, such as the CAN bus understands them as well. And actually at the bottom there's a little aluminum piece here, and it's a heatsink to make sure that the board can cool down a bit when it's computing a lot. But now we're going to focus on the debug interface, and specifically these six holes. So what we want to do is be able to read and write the information that's going over it to see if we can exploit it. So there are 6 holes, and typically there are 4 headers. The the current, the ground, and the transmit and receive. So if you hook up the current, it has power to operate on. There should always be a ground connector to make sure there is a closed circuit, and then the transmit and receive to be able to communicate to the port. And we can identify those using a multimeter. So first, the ground. Every component on the board is grounded, as I said, to make sure there's a closed loop. And to be able to identify other grounded pins, you can simply take one of those grounded components and do a continuity test. Put your multimeter on the right setting, and if you hear a beep, you know that they're both grounded. And a really easy component that you know for sure is always grounded are big metal shieldings. So at the bottom we see two big metal shieldings for the SIM card and for the micro USB. And if we just take our multimeter and put it on the big metal piece, and then go over all the holes one by one, at some point we'll hear a beep and we know which hole is grounded. And turned out that the bottom left one beeped. So first pin identified. Then the transmit pin. So that's the hole out of the 6 where the debug interface transmit data back to us. Data transmit, it's binary. It's a 0 or it's a 1, and the board operates on 3.3 volts. So there will always be 0 volts or 3.3 volts. But the multimeter is not fast enough to read all that. So you see the volts just fluctuating a bit between 1, 2, and 3, just going up and down. And when we measure all the holes except for the ground, we see the following. We see a few 0 volts, but we see the second one from the top is actually variable. It moves around. Sometimes it goes up to 3.3, sometimes to 2.5. So that's an interesting candidate for the transmit port. And the moment when the board is transmitting the most information is on boot up. When you start your normal computer, you see a lot of text scrolling over the screen. That's all debug information that's just written out. That's the same thing what this interface is doing as well. So when you boot up the board, that's the moment when you want to measure these values. So we have one candidate for the transmit. We don't really know where the receive is yet, but maybe we'll see later. As I showed you before, there were just holes there, and you can't connect to holes, so you had to have something to connect to. So we soldered these pins onto the hole. Just simple soldering. And then there's this little device that you can use to communicate to it. And you can see the big beta on the screen. There are these little pins that you connect to the interface themselves, and the USB cable goes to the computer. And you have to tie in the pin's ground adapter, which is on the left. And then where the board transmit data, you want to receive that as the interface. So the adapter's receive pin had to be connected to the 0 port's transmit pin. So as I said before, we had one pin where we thought that was the transmit, so there we had to connect the receive of the adapter. Then we booted up our computer, we opened the device manager. That's where you can see which type of devices are all connected to your computer. And then when you plug in the USB cable into your computer, you see that something happens, that something shows up in the list. And we saw this COM port, so we had a connection. And then we set up our terminal, and you have to know a few settings before you can communicate to this interface. You have to know how fast it's talking, how many bits per second. You need to know the way it's talking, if it's starting with a certain bit or stopping, or if there are pause bits, etc. We didn't know any of those, so we just started with the default settings, and we didn't see anything. So that was kind of a bummer. But the main thing that we need to figure out is the speed that it's sending. So if it's sending 9600 bits per second, or maybe 1515200 bits per second, we didn't know. So we're just gonna try a bunch of values and see if something happens. And we see when we fill in the 38400 that we see something. It's not readable yet, but it's more than nothing. We already see something. So let's go higher. 115,200. We see more, still not readable. But now we ran into all the default baud rates. If you Google for various baud rates, you see this list. You don't see anything more, and we still don't see anything. So you have to calculate more baud rates as a way you can calculate as a formula. So we calculated a a bit higher ones. And if we fill in a really high one, we suddenly see text. So it means we're actually receiving data from the board when it's booting up. It's a lot of data, it's going line by line, it's scrolling really fast. So we pulled out the board, we scrolled back up at our terminal, and we actually saw something that looked like a menu. I don't know if you can see it on the screen, but it says debug menu, and it says some options: A, test CVM, B, test CAN, and here is C, test data. So there's some debug output, some gibberish with an actual menu in there, which is quite cool. So we at least got some information from the board already. It's talking to us. So now that we want to interact with this menu, we need to find the receive pin of the board. We can transmit data into the receive pin of the board. We have 4 candidates left out of the 6 pins. So now we need to go about finding the right one. Same thing. We take a UART, but now we plug in the ground, the receive like we did before, and then transmit just on one of the other holes that we had left open. So again, receive on transmit because we're transmitting and the board is receiving and the other way around. And then we booted up the device, we connected all the USB, all the cables, and we just pressed A just to see if something is going through. And we didn't see anything changing when we used the first hole. With the second hole, similarly, nothing happened, but we just hold down the A button. And then for the next one, we suddenly see something happening. We see that we don't understand what it is, but there is something different there. So it seems like it's responding to the A button that we're holding down, that it's actually responding to it, so we're able to talk to it, which is quite cool. So now we found all the pins. We found the ground, transmit, and receive, so we can send data, we can receive data. So let's look at this debug menu. We saw these options scattered here together with the debug information. It's going way too fast for us to wait till we see this and press an A and then press the following button to dive into the menu. So we automated a bit. We wrote a script that automatically operates with the board. It's something like, if you see this A, press an A. If you see this B, press a B. And that way we could map out the entire menu that existed within the box. And it's listed out here. You have these. What you see is that there's a 2-level menu. So you have A, B, C, D at first, and then once you're in there, you have 1 till how many more options to do all these tasks. When going through there, we saw one quite interesting option. I think one developer was quite frustrated. I hope you can see it everywhere, but it says get sensor uncalibrated shit temperature value. I don't exactly know what was going on there, but when taking a look at it, I do understand what he's saying. It's just some numbers, but apparently there's a temperature sensor in the Mindbox somewhere which just gives some numbers. It's quite funny to see this text, which the developer probably thought no one would ever see, and now it's on YouTube. And that's about as far as we got with the debug interface, with the physical interfaces. So we got a working connection, we could read and write, but the debug options, the whole menu that I showed before, didn't really have any really interesting features. We thought for a second that we could change the braking and the steering options or the thresholds that rate your driving skills, so you could artificially be at 100% all the time, but we didn't manage to do that in the end. So luckily, not a very high risk. We didn't have to pull back all the Mindboxes that were already installed. Then moving on to the last part, one of the big questions was, can you make sure that it's really not possible to write to the CAN bus? So even if you manage to hack the device, that you cannot control the car through the device. So I mentioned a few components already before. There's the processor, which is the brains of the board. There's the CAN controller and the CAN transceiver, which translate the data that the processor is sending, such that the CAN bus understands. And there's the connector itself. And these have to be connected in a certain way to allow for this communication. So there should be a connection from the controller to the transceiver to the connectors, and those were all present there. It just worked because we need to be able to read data, so there needs to be a connection. At the bottom, you see there's this self loop from the controller from one hole to the other, and that was to facilitate the reading functionality. They had to be connected. That was in the specification of that chip. And we actually see that connection is missing for the write. So on purpose, the developers of this board left out the self connection to facilitate the write option. And the same thing we saw from the processor to the controller. There was no connection from the processor to the CAN controller. So they took two measures to prevent write access to the board. So we could say, yeah, we didn't. You're right. We did not achieve in writing to the board. Maybe one question: we did solder on pins for the first part. Why didn't we solder anything here? Well, if you have your box, you have your own thing, you break it apart and you make it working that it can write data to the CAN bus, that's cool, but it's your own car. You can push the brake in your own car, well, you can already do it by just sitting in it. What we wanted to know here is if you manage to hack the box through a wireless interface, through the central gateway, if then you wouldn't be able to control the car. And that's what we confirmed here. So the conclusion of the test that I executed is that there are no high-risk vulnerabilities identified. We weren't able to control the car. We weren't able to do any physical harm, to do any financial harm. Possibly some reputational harm if we would publicize these findings, that we have some connection that shouldn't be there. There was no we didn't achieve any write access to the CAN bus. For the debug interface that we found, we did some recommendations, and they actually will be patched on the systems. There's an over-the-air update system on the CAN bus, so wirelessly they can update the firmware, and there they will do an update such that even the interaction with the board is no longer possible. Maybe some next steps as a broader whole on a way to connected cars from where we are now. It's quite different from traditional IT, the stuff that I started with, the web applications, the mobile, the infrastructure. It's a whole different way of testing of how you do that. So you really have to think in a different way and know a lot of different stuff. Connected cars are coming. Manufacturers are working on it. Government bodies are trying to regulate it. A lot of people are talking about it, thinking about it. I think what's really important is to come up with industry standards, such as the CAN bus that was introduced in the beginning of the 90s, that every car is using right now. This way we can make sure that if Volkswagen buys different components from different vendors, they all can communicate in the same way. We need similar things for connected cars to make sure they are created and operate in a safe way. And that was my what I have to say.
Maybe one question I have is, because you now tested the Mindbox, but what now if you connect it directly to the CAN bus in the car? So checking if you can have direct access, not throughout the box, but directly. Is that something that you could test as well, or would that be interesting?
Well, that's already being done. If you go to your dealer and you have some error code, they plug in a machine in the CAN bus to read out those error codes.
So that's all only receiving, or can you also?
You can also write there, yeah.
Yeah. And do you know if that's well protected? Because that's even.
It's not.
It's not. Okay.
No. So the thing that happens is you have this thing that is not protected, and suddenly people start putting internet connected stuff on it. So just the CAN box.
Yeah.
But also your modern radio. Maybe you can show a nice weather icon, so it needs an internet connection.
Yeah.
And it's also connected to the CAN bus. And what I said that people that a possibility would be to push the car's brake just from your couch. That has been done. People have tested that and have executed it. So there's definitely some regulation needed to make it all go smoothly and safely.
Okay. Well, thanks a lot, Colin. Thanks for all the hard work you did.
Question also.
Another question?
Yeah.
I'm technical about this stuff, and according to me, the Mindbox is the same as a modem. Actually, like a modem. But did you investigate also the SIM card vendor? According to me, they're connected via the SIM card delivered to generate data.
Yeah, there's I think a KPN SIM card in it, and they have their own AP, which is connected to, and then it goes on to the central infrastructure.
You have to take the Russian SIM card?
It didn't work. No.
Yeah, they deliver also SIM cards. It can be.
Yeah, it was the firmware of the Mindbox was programmed to only accept KPN SIM cards.
Okay. also KPN can be able to access those Mindboxes by their own network.
Probably, yeah. But I guess that's the risk with any external vendor that you include in your system. That you have to trust them that they don't do anything weird with your data.
Trust on the blue eyes or on the tech?
I hope that the Mind guys did a bit more than trusting them on the blue eyes.
Thank you.
Okay.
Another question from Tim Milgaard. He's asking if you tried other type of hacking than just the debug interface.
No.
Okay.
No, this is as far as we got in the few weeks that we had.
Okay, thanks.
How many time did it take to check the security level of the Mindbox?
The test took in total, I think, 6 days.
Okay.
And this most of this story was put together in like a day.
Thank you.
Okay.
Well, we can all see it's quite simple to hack a Mindbox, so you can try this at home as well. Thank you. Before we finish off, I started to talk about the DNS issue, the agile way of working, and empty systems. Any questions about that? Those topics? No? Okay, then thanks for your time, thanks for your attention. See you next time.
Thank you.